Hey everybody, once again it is Monday, off to a new week. Today is April 20th, and actually we have 1 month until the very last day of school. The last day of school is May 20th, and which is 1 month from today. So that's kind of exciting. Seems like this school year has gone by really fast. I guess the last month has been pretty weird, and obviously the next month is going to be as well. Definitely not how we expected to end the school year, but this school year has flown by. I feel like to the fact that we only have a month left is just crazy to me. But we're going to go ahead and get started with today's lessons. But before we do that, there's something I kind of want to talk about with Canvas. So some of you are having issues finding Friday's lesson on Canvas. Which is okay. I mean, there were multiple people that were having issues. Just so you guys know, there's not going to be a day, Monday, Wednesday, or Friday, where I'm not going to post something. Okay, so some of you you went and you just assumed that, oh, he doesn't have anything posted, I don't see anything, so I guess I don't have to do anything for math today. There's always going to be something posted on Mondays, Wednesdays, and Fridays. Okay, so if you don't see something, you gotta look a little bit to be able to find it. Okay, so typically, like if this is your home page right here, right? A lot of times you're going to be able to find it here on the right side. And by the way, your screen isn't going to be in pink or purple or whatever this is, by the way. Mine turns purple when I go to student view, so I click on student view so I can actually see what students see. Okay? So a lot of times when you come to Canvas, your assignments are going to be posted right here on the right, the to-do section. Okay, if you don't see anything there, go over here to the announcements tab, or not the announcements, sorry, not the announcements, the assignments tab. Okay, and I post weekly assignments in a group. Okay, so like you can see each of these groups: week 1 e-learning assignments, week 2 e-learning assignments, week 3, week 4 was last week, and week 5 is this week. So you can see today's Monday, which is 4/20, and you can see right here today's assignments posted. Okay. Last week, you should have been able to see all 3 assignments right here. Monday 4/13, Wednesday 4/15, and Friday 4/17. Okay. Now, for some reason, some of you weren't able to see all of these right here. Like you weren't able to see Friday's assignment posted here. I don't know why. Okay. Like if I click on student view, I can see it right here like normal. Okay. Like I posted it there just like every other assignment. So I don't know why. For some reason, some of you wasn't showing up here. Okay, so it wasn't showing up on home, it wasn't showing up on assignments. If it doesn't show up on either the home page or the assignments page, there's a good chance if you click on quizzes that it'll show up on the quizzes page. Like you scroll down right here, you can see these 2 surveys right here. There's Monday 4/13 and Friday 4/17. Okay, there's a good chance you might see that day's assignments there. So if you don't see it on home, if you don't see it on assignments, check quizzes just in case, the quizzes tab here, to see if it's posted there. Now if you don't see it on any of those 3 sections, then you probably want to email me just to see and make sure if where the assignment is posted. There could be an error, I don't know, but I'll do my best to get it all sorted out for you. Okay, but don't just assume that we don't have one if you don't see it right away. Okay, all right, so that clears that up. So let's go ahead and get started. The objective for today is to find the probability of a compound event. So we talked about simple events already. That's when you have one thing that's happening, right? Let's say you roll a dice. That's a simple event. You roll it once. That's a simple event. Only one thing is happening. A compound event is when more than one thing is happening. So maybe you roll a dice twice. Or maybe you flip a coin and then you roll a dice. Or maybe you pick a card and then you flip a coin, or something like that. Basically, you have 2 events that are happening. Okay, so here it says finding probability using a table. So it says recall that a compound event consists of 2 or more simple events. So you could have 2 events happening, 3 events, 4 events. It's basically 2 or more. To find the probability of a compound event, you write a ratio of the number of ways the compound event can happen to the total number of equally likely possible outcomes. I just need to take a drink. All right, so first example. Elias rolls 2 fair number cubes. So basically the number cube is just a dice, right? I don't know why the book loves to call a dice number cubes. We're just going to call them dice, or you can call them number cubes. Either way, whenever it says number cubes, it refers to dice. So Elias is rolling 2 dice. Find the probability the sum of the numbers he rolls is 5. So we want to know how likely it is that he rolls them, and the 2 numbers that show up add to 5. Now you might think, ooh, that's complicated, right? Now what we're going to do this is we're going to use a table to find the sample space rolling a particular sum or 2 number cubes. Now when it says sample space, a sample space is basically a list of all the possible outcomes that you could get from rolling 2 dice. Okay. Each cell is the sum of the first number of that row and column. So if we look here, we've got this table. We're going to fill this out. So he's rolling 2 dice. It says use the table to find the sample space for rolling a particular sum on 2 number cubes. So let's say he rolls a 1 and a 1. A 1 on his first die. This is the first die. Let's say this is the second die. So let's say he rolls a 1 and a 1. The sum of that is 2. Okay. Let's say he rolls a 1 and then a 2. Well, that sum is 3. If he rolls a 1 and 3, that's 4. If he rolls a 1 and then a 4, that's 5. A 1 and then a 5 is 6. And then last, a 1 and a 6 is 7. Okay, so these are all the possible outcomes that we could have. If he rolls a 1 on his first die, these are all the possible sums that he could have based on each of these outcomes, right? So if he rolls a 1 first and then a 1 second, he gets a sum of 2, and so on. Okay. Now let's say he rolls a 2 on his first roll, and then a 1 on his second roll. That sum is 3. If he rolls a 2 and then another 2, that sum is 4. A 2 and a 3 is 5. And we have 6, 7, and 8. Okay, if he rolls a 3 on his first die and a 1 on his second, that's a sum of 4. Okay, then 5, 6, 7, 8, and 9 for a 6 on the set, right? 3 plus 6 is 9. So you can kind of see the pattern that's going here. If he rolls a 4 first and then a 1, that's 5. Then he's going to get a 6, 7, 8, 9, and then he could get a sum of 10 that way. Okay, if he rolls a 5 first and then a 1, that's 6. Then he could get a 7, 8, 9, 10, and 11. If he rolls a 6 first and then a 1 on the second, that's a sum of 7. Then there's an 8, a 9, 10, 11, and 12. All right, so this is our sample space. Okay. This is our sample space right here. This is a list of all the possible outcomes that we could get from rolling 2 dice, right? These are all of the possible sums of the 2 dice that we could get. The lowest sum possible is 2. The highest sum possible is 12. Okay? So this first question says, how many possible outcomes are in the sample space? How many are there, right? Well, there's 1, 2, 3, 4, 5, 6. So each row has 6, and then there's 6 rows. That's a total of 36 possible outcomes. Okay. Step 3, circle the outcomes that give a sum of 5. Oops, I already circled a couple. Let me erase these 2, and I'll redo them. So this should be 2 and 3. So we want to circle the outcomes that give a sum of 5. Remember, our goal is to find the probability that the sum of the numbers he rolls is 5. So now that we have all the possible outcomes, let's circle the ones that give a sum of 5. Well, here's one right here. If he rolls a 4 first and then a 1. Here's one. If he rolls a 3 and then a 2. Here's one if he rolls a 2 and then a 3. And then here's one if he rolls a 1 and then a 4. Okay, so I see 4. I don't think there's any others in this table that has a sum of 5. So there's 4 different ways that he could roll a sum of 5. So then the probability of rolling a sum of 5, well, we said there's a total number of 36 outcomes. Of those 36, 4 of them give a sum of 5, right? So our probability is 4 out over 36. This can then reduce. 4 over 36 reduces to 1 over 9. So he's got a 1 out of 9 chance of rolling a sum of 5 with 2 dice. Okay? All right. Now, it says, give an example of an event that is more likely than rolling a sum of 5. So, let's look here. Are there any numbers you can see here that occur more than 5? Right? Because our goal here is to give an example of an event that's more likely than rolling a sum of 5. So, the likeliness of getting a sum of 5 is 4 out of 36. Do you see any number that shows up more than 4 times? Well, yeah. The 6's show up 5 times. The 7's show up 6 times, and the 8's also show up 4 times, or 5 times. So 6, 7, and 8 are all more likely sums than 5. Okay. Number 2, give an example of an event that is less likely than rolling a sum of 5. Well, that is anything that's less than 5, right? So here there's 4 5s, so 4, there's only 3 4s, there's only 2 3s, there's only 1 2. Over here we can see there's only 3 10s, 2 11s, and 1 12. Any of those numbers would work there. Okay. All right, so here we have Drake rolls again. He's got 2 fair number cubes. He's rolling 2 dice. This says now complete the table to find the sample space for rolling a particular product on 2 number cubes. So on the last one we did sums. On this one we're going to do products. Okay, so first we want to multiply. Product is multiplication, so we're going to do 1 times 1 first. That's a product of 1. Then 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 1 times 5 is 5. 1 times 6 is 6. Okay, that's our first row done. Now let's say we roll a 2 on our first die and then a 1. That's a product of 2. Then 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. And 2 times 6 is 12. Let's say we roll a 3 on our first roll. And then a 1. 3 times 1 is 3. 3 times 2 is 6. Then 9. 12. We can see we just have all multiples of 3 here. 15. And then 18. If he rolls a 4 first, 4 times 1 is 4. Now we have multiples of 4. 4 times 2 is 8. 4 times 3 is 12. Then 16. Then 20. And then 24 is 4 times 6. Let's see if he rolls a 5 first. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 20. 25. And 30. And then the last one is if he rolls a 6 first. So 6 times 1 is 6. 6 times 2 is 12. Then 18. 24. 30. And 36. All right. So this is a table listing all of the possible outcomes for the products of rolling 2 die. Number 2, what is the probability that the product of the 2 numbers Deshawn rolls is a multiple of 3? A multiple of 3. So we want to look through here and find all the multiples of 3. So let's circle the multiples of 3. Okay. Actually, I'm going to put like a little X in the multiples of 3. So here's an X that's a multiple of 3. 6 is a multiple of 3. Here's another 6. 12 is a multiple of 3. All of this entire row are going to be multiples of 3, right? Including this entire column is also going to be a multiple of 3. Okay, 4, 8, 16, 20, 24 is a multiple of 3. 30 is a multiple of 3. And 36 is a multiple of 3. Also, 6, 12, 24, and 30, those are all also multiples of 3. So basically we've got these are multiples of 3, these are multiples of 3, these are multiples of 3, and these are multiples of 3. Okay? So the probability, so again, there's 36 possible outcomes still. How many of them give us a multiple of 3? Well, we can count them, right? Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 possible outcomes give us a multiple of 3. So the probability then is 24 out of 36. this can be reduced, right? So 24 and 36 can both be divided by 12. 24 divided by 12 is 2. 36 divided by 12 is 3. We have a 2/3 chance of rolling a product of, or a multiple of 3. All right, number 3. What's the probability that the product of the two numbers Deshawn rolls is greater than 11? Okay, so here, let me do a different color for this. So now we want to circle all the numbers that are greater than 11. So here is 12 is greater than 11. 12, 15, and 18 are greater than 11. 12, 16, 20, and 24 are greater than 11. 15, 20, 25, 30, those are all greater than 11. And then 12, 18, 24, 30, and 36 are all greater than 11. Okay, so now the number, we'll count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 possible outcomes that are greater than 11 out of a total of 36 outcomes. And this cannot be reduced any further, so our probability there is 17 out of 36 chance. Okay? Next, finding probability using a tree diagram. You can also use a tree diagram to calculate theoretical probabilities of compound events. So a deli prepares sandwiches with one type of bread. You can get rye or wheat, one type of meat, ham, turkey, or chicken, and then one type of cheese, cheddar or Swiss. Each combination is equally likely. Find the probability of choosing a sandwich at random and getting chicken and cheddar on rye bread. Okay? All right, so let's say we just pick a random combination. What's the we want to know the probability of getting chicken cheddar on rye. Now, this might sound difficult, but one thing we can do, so I mean we just talked about doing it using a table. We can also use something called a tree diagram. Okay, so I'm going to show you how to do that right here. Okay, so when you're doing a tree diagram, first you want to list all of the possible events that you can have. Our first event is we're going to pick a type of bread. So first we're going to list breads. And then I'll underline that. Okay. Our next choice is the type of meat. Okay, so I'll list meat here, and I'll underline that. Okay. And then third is we're going to list a type of cheese. So I'll do cheese, that's my third event. So I'm listing all of my events at the top, underlined, kind of like column titles basically. Below bread, I'm going to list the different types of bread that we could get. So we could get rye or wheat. Now I'm going to abbreviate these, R and W, for rye or wheat. Those are my two choices for rye or wheat. Next, event number 2, so that was event 1. Event number 2 is what types of meat. So the types of meat I could get are ham, turkey, or chicken. Now, what I'm going to do here is I'm going to list each of these options for each type of bread. So if I pick rye first, there's 3 meats that I could get with rye bread. I could get ham, I could get turkey, or I could get chicken. Okay. If I pick wheat bread, I could also get 3 types of bread, or 3 types of meat: ham, turkey, or chicken. Okay. So if we're just picking between bread and meat, I have a total of 6 possible choices. I could get rye with ham, rye with turkey, rye with chicken, or I could get wheat bread with ham, wheat bread with turkey, or wheat bread with chicken. So there's 6 possible choices so far. Now let's throw in the cheeses. Okay, there's 2 types of cheeses: cheddar or Swiss. So branching off from each of these meats, now we're going to list the types of meat. So I'm going to do CH for cheddar, just because C is for chicken. CH for cheddar, and then S for Swiss. I'm going to branch off for each one. So cheddar and Swiss, and this is going to get crowded. Ugh. For chicken, I'll do cheddar and Swiss. Okay, and then I'll do the same thing for these. Cheddar, Swiss, cheddar, Swiss, and cheddar, Swiss. Okay, now I know this is super dense. I didn't give myself a ton of room to work here. Whenever you're making a tree diagram, you always want to make sure that you have plenty of room to write. Yeah, otherwise you're going to get kind of crowded like I did here. All right. So now, how many possible outcomes are there now? Well, there's rye with ham and cheddar. That's one outcome. There's rye with rye with ham and Swiss. That's a second outcome. Okay. Then rye with turkey and cheddar. So rye with turkey and cheddar. That's a third outcome. Or you could have rye with turkey and Swiss. That's a fourth outcome. Rye with chicken and cheddar. That's a fifth outcome. Rye with chicken and Swiss is 6. Now down to the wheat breads. Wheat with ham and cheddar. That's 7th outcome. Wheat with ham and Swiss. That's 8th. Wheat with turkey and cheddar. That's the 9th outcome. Wheat with turkey and Swiss is 10th outcomes. Wheat with chicken and cheddar is the 11th outcome, and then wheat with chicken and Swiss is the 12th outcome. Now, just to make sure I did that correctly, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes, right? So our sample space are all these possible outcomes that we could list. Step 2 is find the number of possible outcomes in the sample space. We already said that's 12. And then find the probability of choosing chicken and cheddar on rye bread. So we want to figure out the probability of chicken on cheddar with rye bread. So what we need to do here is we need to find all the possible outcomes that give us chicken and cheddar on rye bread. So first, the rye bread needs to be rye, or the type of bread needs to be rye. The meat needs to be chicken. The cheese needs to be cheddar. There's only one outcome, rye with chicken and cheddar. There's only one possible outcome that gives us that specific combination. Okay, so the probability of choosing chicken and cheddar on rye is 1 out of 12 possible combinations. So it's 1/12 of a probability. Okay, and then this last slide, it says use the tree diagram from example 1 to find the given probabilities. Let's say we just want to know the probability of getting a turkey sandwich. Well, let's come back up here. We want to find all the possible outcomes that have turkey in them, right? Well, here's turkey. Oops, let me get my pen. Here's turkey, and here's turkey right here, right? So rye, turkey, and cheddar, rye, turkey, and Swiss, and then there's wheat, turkey, and cheddar, and wheat, turkey, and Swiss. So here's 2 outcomes right here. Here's turkey and cheddar, turkey and Swiss. That's 2 more outcomes. So that gives us a total of 4 possible outcomes, which is 4/12 of a probability, which reduces to 1/3. And then we want to know the probability of getting a sandwich on rye bread. Well, here, all of these outcomes right here are all rye bread. That's 1, 2, 3, 4, 5, 6. So that's 6 out of 12, which is a 1/2 probability. Okay? All right, so your assignment for today is on Edulastic. It's the 15.A11 on tree diagrams. Okay, so go ahead and head over to Edulastic. You can complete that. Just a reminder, Wednesday at 1 p.m. will be the next Canvas Live Q&A with me. If you have any questions over this assignment or any other assignment that we've done, feel free to come on by on Wednesday. It was great to see a couple of you on Wednesday and chat with you a little bit. If you do have any questions or you just want to come by and say hi, feel free to come by Wednesday at 1 p.m. I hope to see you then. Have a good day, guys.